All right, I've been able to mute the person, so I think you can hear me well. Maybe someone can confirm, please.
Hello?
Yes. Weber, can you hear
Yes,
me?
I'm getting you.
All right, then that means the rest of the members also are hearing me well. So I want to take this opportunity to invite you all to this Space Club webinar series that we've been conducting since Monday. It has been a very successful week from our end, and I believe from your end also you've been gathering a lot of information on our space sector. So maybe I'll just briefly share what we have done since Monday. So I believe you can be able to see my screen here. We started with an introduction to geographic information systems on Monday, and then Wednesday we had an introduction to Scratch programming, where we were able to kind of come up with a solution on how to do programming on Scratch. And then yesterday we were able to do an introduction to satellite ground station, and I believe you guys were able to understand how ground station works and why it is important for us to be able to implement a ground station. So today we are having another presentation related to the space sector and specifically space science and astronomy. So the introduction will be on, the presentation will be on introduction to gas giants, and we have our presenter for the day, who is a space scientist at the Kenya Space Agency, and he's going to take us through this presentation. So before I let him begin his presentation, maybe I'll just briefly introduce myself. My name is Guyo Galgalo, and my background is in electrical engineering. At the agency, I support in research and innovation, as well as education and outreach. So I want to welcome you all, for those who have been able to join us, to be able to listen in this webinar and learn and ask as many questions as you have with regards to space science and astronomy, and the presentation for the day, and any other related question that is relevant to the space sector, we'll be able to answer them. So karibuni nyote, welcome, and I invite Weber to begin his presentation.
Hello, good afternoon.
Good afternoon. We can hear you well. You can begin the presentation, please.
Okay. Well, I welcome all those who are going to participate in this webinar. Allow me to introduce myself. My name is Weber Chemwanges. I work at Kenya Space Agency. My background is astronomy and astrophysics. And in today's webinar, we are going to look at our topic today is Introduction to Gas Giants. And I'm going to highlight what you're going to cover in the webinar. That is the summary of the content. Okay. Now, what you're going to cover today, as you can see, we're going to look at the introduction to gas giants. Okay, sorry for the delay. We have been handling some technical problem. We shall also look at the characteristics of gas giants. Also the what is this? We shall also look at the Kuiper belt. We shall look at the cases of exploration of gas giants, also the careers related to astronomy and astrophysics. We shall look at the activities that a student can partake while modeling the gas giants planet system. Okay, as we try to among the content, we shall also look at the gas giant examples. Okay, maybe I just recap on the contents that we are going to look at: introduction to gas giants, characteristics of the gas giants, examples, the Kuiper belt, exploration of gas giants, careers, activities, and the question. We shall give you an opportunity to ask questions regarding today's webinar. Okay, maybe just to start with, I would like to know, what do you understand by the gas giants? We looked at the terrestrial planets. I'm sure you still remember if somebody asks you to describe what is a terrestrial planet. But now we want to look at what is we look at the gas giants. So anybody who has a clue of what it means, you can include your views in the charts. Now, by definition, a gas giant is defined as those planets that are made mainly of gases and they do not have a solid surface. It's just as simple as that. Now, compared to terrestrial planets that are mainly made of solid, right from the core all the way to the surface. But for the case of gas giants, it's only the core that is made of solid, and we are going to look at the general structure that will indicate that. So gas giants are mainly made of gas. It's only the core that is solid. Okay, looking at the characteristics of gas giants, we have here a diagram showing the general features of a gas giant planet. The first one, you'll find that they do not have a solid surface. Secondly, they have a rocky core, and then they're mainly composed of gases which are lighter. And when we look from the diagram, the gases we are talking about here include hydrogen, helium, and methane. That is what makes the atmosphere of the gas giant planet. When you look at the diagram also, you see that the mantle is made of water, ammonia, and methane, and also ices. And the core is a rock and ice. Another thing about the characteristics of gas giants, they're usually bigger when you compare them to terrestrial planets. Their sizes are much, much bigger. Also, they have many moons, something that we're going to look at later when we'll be looking at each of the planets, the characteristics of each of the planets. Okay. We all know that in the solar system, we have the 8 planets, but the gas giants, they form the last 4 of the planets. That is from Jupiter, Saturn, Uranus, and Neptune. From the first one to the 4th one, we already covered in the previous webinar. we understand they are solid, that is terrestrial planets, Mercury, Venus, Earth, and Mars. In between, you have the asteroid belt, and then you cross over to Jupiter, Saturn, Uranus, and Neptune. So the last 4 planets are the gas giants. Now, narrowing down to each of the planets, and starting with the Jupiter, the temperatures